Hello guys, today we will discuss binomial theorem proofs by using induction, Pascal's triangle rule, and choose K method. In the end of the video, we will consider several applications of this. Binomial theorem tells us that x plus y to the power of n equals sum of the n choose I times x to the I times y to the n minus I power. To prove this, at first use the induction method, and if n equals 1, we will get x plus y to the power of 1 must be equivalent of 1 choose 0 times x plus 1 choose 1 times y. And clearly this is correct. Now we are assuming that this is correct up to n equals k and show that this will be correct for k plus 1. So x plus y to the power of k equals k choose I times x to the I times y to the k minus I. The I changes from 0 to k. And we want to show that this will be correct for n equals k plus 1, which can be rewritten as x plus y to the power of k plus 1 equals to k plus 1 choose I times x to the I times y to the k plus 1 minus I. Similarly, I here changes from 0 to k plus 1. But by using induction, we know that x plus y to the power of k plus 1, this one can be rewritten as x plus y times x plus y to the power of k, which can be written as x times x plus y to the power of k plus y times x plus y to the power of k. Now we can use the inductive hypothesis. So we will get x times I changes from 0 to k choose I times x to the power of I times y to the k minus I plus y times I changes from 0 to k choose I times x to the power of I times y to the power of k minus I. And here we need to group the terms. And for this one, we will use Pascal's triangle rule, which tells us that n plus 1 choose k equals to n choose k plus n choose k minus 1. And how can we apply this here? We can see that if we are searching for the power, like coefficient of x to the I times y to the k plus 1 minus I term, if we want to generate this from here, we need to find x to the I minus 1 times y to the k plus 1 minus I coefficient, which will be clearly k choose I minus 1. And from the second term, we have to find x to the I times y to the k minus I coefficient, which will be clearly k choose I. And now we want to sum up these two coefficients, this term and this term. So we will get final coefficient will be k choose I minus 1 plus k choose I. And if we substitute instead of n k in the above equation, instead of this variable ki, we will get k plus 1 choose I. This is exactly what we wanted, because we wanted to show that x plus y to the k plus 1 can be represented as k plus 1 choose I times x to the I times y to the k plus 1 minus I power. And this is a proof by using induction and Pascal's identity. Now let's do the second proof by using n choose k method. X plus y to the power of n can be written as x plus y n times n times. And if we are searching for the coefficient of x to the k, so we want to show that this equals n choose k times x to the k times y to the n minus k. K changes from 0 to n. We want to find, like, from each parenthesis, we choose either x or y. And as we want to find the coefficient of x to the k times y to the n minus k, this means that we have to choose exactly exactly k x's and n minus k y's out of these n brackets. And so we have to choose k brackets where we will take x out of n brackets. And this can be done by using n choose k method, which tells us if we are given n people in a row, how many ways can we choose any k of them? If you have any questions about n choose k method, please write in the comments and I will clarify this once again. And because of this n choose k method, we can easily see that coefficient of x to the k times y to the n minus k will be exactly n choose k. And finally, see several examples of binomial expansion. If we are given this kind of sum, n choose 0 plus n choose 1 plus n choose 2, n choose n, prove that this will be equivalent of 2 to the power of n. You can pause the video and try to find the solution by using binomial expansion. Okay, now I will tell you the solution. As we already proved that x plus y to the power of n equals k changes from 0 to n choose k times x to the k times y to the n minus k. And if we substitute instead of x and y, both of the elements equals to 1, this value can be substituted as 1 plus 1 to the power of n, which will be exactly 2 to the power of n. And each term here will be rewritten as n choose I, sum of the n choose i's, because x to the k and y to the n minus k, both of the terms will be 1s. So k changes from 0 to n choose k times 1 to the power of k times 1 to the power of n minus k. And so we prove that this sum will be exactly equivalent of 2 to the power of n. You may see that both of the sides compute the number of subsets in n element set. And we can see that n choose k counts the k size subsets of any element set. You can also use this formula. So another very well-known formula about binomial expansion is that n choose 0 minus n choose 1 plus n choose 2 and so on. Here we have pluses and minus alternating. For the final term, we don't know what is it. This is minus 1 to the n power times n choose n. This value will be always equivalent of 0. Here you can also stop the video and try to find the solution. In this problem, the idea is to use x equals 1 and y equals negative 1. And we will see that in our expansion, x plus y to the power of n, this one can be rewritten as 1 minus 1, which is clearly 0. K equals 0 to n choose k times 1 to the k times minus 1 to the n minus k. And if we expand, if n minus k is even number, we will have positive term, and if it is odd number, we will have negative term. And we can easily see that this term will be exactly what we wanted, because this will be expanded as n choose 0 minus n choose 1 plus n choose 2 and so on. Final term will be minus 1 to the power of n times, and choose n. So we prove that the sum also equals to 0. And final, a bit hard example is if we are given to find k equals 0 to n, and choose k times t to the power of k. For this kind of sums, we will prove that this is equivalent of t plus 1 to the power of n. Once again, we will use binomial expansion, x plus y power of x plus y to the power of n. This equals to n choose k times x to the k times y to the n minus k, where k changes from 0 to n. And if we substitute x equals t and y equals 1, this one can be rewritten as k changes from 0 to n, and choose k times t to the power of k times 1 to the power of n minus k, which is exactly our sum. And as we know that left-hand side is t plus 1 to the power of n, we have proved our final example. If you have any questions, please write in the comments, and don't forget to like and subscribe my videos. This will give me a lot of motivation.